Okay, last problem in this section. The complete graph of a polynomial function whose zeros are integers is shown. Do the following. So there is a graph. I'll zoom in a little better so we can see the graph a little bit better. So there's graph. List the zero whose multiplicity is even. And so the key is right there. That's touch turn. Even multiplicities are touch turn. And so that would be x equals -2. List the multiplicity who is odd. That's cross. Cross is x-axis. Touches turns, x-axis. And so that would be x equals 4. So first two things, pretty easy. Now it gets a little more complicated. Write an equation expressed as the product of factors of a polynomial function that might represent the graph shown. Use a leading coefficient of 1 or -1 and make the degree as small as possible. Okay, what they're asking for here. They're asking for a formula that could possibly represent that graph. That if I gave a formula and I graphed it, it would give me that picture. Or something that was close to that picture. So we got to remember some things we said a couple pages ago. Can we find them? Yeah, right here. That if I know that a number is a 0, I also know a factor. That if c is a 0, then x minus c is a factor. That if I know a 0, I know a factor. And so notice what it says here, as a product of factors. And so because, I'll go out a little bit now. Because x equal -2 is a 0, then x minus -2 is a factor. And then because it has an even multiplicity, we will say x plus 2 squared is a factor. Now, square, because they said make the degree as small as possible. Technically, I could have picked any even number, 2, 4, 6, 8, 10. But they did say degree as even as possible. And similarly, because x equal 4 is a 0, then x minus 4 is a factor. And we have an odd multiplicity. And so that would mean that x minus 4, technically to the first, is a factor. So the answer is either, now that's strange, but we'll talk about that in a minute, f of x equal 1 times x plus 2 squared, x minus 4, or f of x equal -1 times x plus 2, x minus 4. That is one of those two guys, and we have to figure out which one. Now, we could do it analytically, or since most of us have machines, let's use a machine to help us. And then we'll also do it analytically. Let's graph this guy right here. If I graph that one, can we see that? Yeah, you can see that. So y equals, and I'm going to graph that guy right there. So very technically, 1 times x plus 2 squared times x minus 4. Just graph that one, standard window. We'll see what we get. Zoom 6. Now, it's not a great graph, but let's compare that to the picture they gave us. And that doesn't have the right end behavior. It has the touching and turning okay, it touches and turns where it's supposed to, and it crosses right there, but this has the wrong end behavior. So when I check this guy, this isn't it. That has the wrong end behavior. But if I check the other one, so let's just go and put a 1 in there. So now I've got -1, and graph that one. Again, not a great graph. I'm not seeing a great graph here, but good enough. Can we bring it in here so you can see it all? There, we can see it beside each other. I do have the correct end behavior. I'm not seeing the very top of the graph, but I don't care about the very top of the graph. I am getting the correct end behavior. It's rising on the left, falling on the right, and then I have the touch and turn, and I have the cross. And so that has the correct one. And so this has the correct end behavior. And so what the 1 or -1 is doing for us is helping us pick the function that has the correct end behavior. The one with the +1 didn't give me the correct end behavior. Now, if you didn't have a calculator, what you would have to do here is you would have to figure out the degree. So the degree here, if I were to multiply that out, that'd be an x squared, and then I have another x there. So my degree would be 3, that's odd. My lead coefficient, 1, positive. So degree odd, positive coefficient, that's falls left, rises right. Again, wrong end behavior. So if you didn't have a machine, you'd have to figure out what the end behavior of this, and then see that that wasn't the correct end behavior, and so that isn't the correct answer. So the way you approach this problem is find kind of a generic formula by determining what the factors are, and then is it +1 or -1, and you pick between the +1 and the -1 by looking at the end behavior. Now the last thing we have to do here, find the y-intercept. Always plug in x equals 0, so f of 0 or y equals f of 0. And so that'll be -1 times 0 plus 2. I'm forgetting an exponent there. There's be an exponent right there. 0 plus 2 squared minus 0 minus -4. So that's going to be -1 times 4 times -4, which comes out to be 16. And that should look reasonable to the graph. So if I zoom in on that graph for a moment there. There we go, zoom in. And it's not going to focus for us. Let's make it focus. We come up with a y-intercept of 16, and that looks like that could be 16. And so all this stuff should check by looking at a picture. Your calculations should match your picture should match your calculations. And so y-intercept, always you plug in x equals 0. We got 16. That seems to match the function. I graphed that. It seemed to match that reasonably well. It's not going to be perfect, but it matches reasonably well. And so we feel good that that's the answer. And that is the end of this section.